Hello students, this is class 10 mathematics. Today we are going to start with a new topic. Today we are going to start with quadratic equation. So before we go into what quadratic equations are, let me just remind you what were the types of equations, what were the type of polynomials that you have learned in class 9. First of all, you have learned what is a linear polynomial, right? Then we have learned what is a quadratic. Then there is cubic. We have also learned something called biquadratic. So if I give an example, linear polynomial, this means the degree or the highest power of the variable, it should be 1. Example is x plus 1. Here you can see that this is the variable and the highest power is how much? The highest power is 1. Quadratic, we will make 1 increment. Example is like this. Here we have got 3 terms, 1, 2, and 3. This one is got the highest power. This one has got the variable. The second term has, although it has got the variable, it is not with the highest power. This one has the highest power. The highest power of the variable is 2, so we will call this as quadratic polynomial. Cubic, here the highest power of the polynomial term, it will be 3. Example will look like this. This is one of the kind of cubic polynomial. Biquadratic polynomial, it will still be the same, except the highest power of the polynomial term, like this. The highest power of the polynomial term, it will be 4. Here the 4 is the highest power, right? But what we are learning here is about the polynomial, isn't it? If all of them, if the linear polynomial, quadratic, cubic, or biquadratic, whatever the type of polynomial, if you equate them to 0, then we will call it as an equation. So example, if we put the linear polynomial, if we equate it to 0, then this is no longer a linear polynomial. This is a linear polynomial, but once we equate it to 0, this whole portion here, this will be a linear equation. Same thing here in the second one, the quadratic polynomial, let's equate it to 0. So we will call it as a quadratic equation. You know that this part is called as the quadratic polynomial, right? This one, if we equate it, the quadratic polynomial, if we equate it to 0, then this one we will call it as a quadratic equation. No need to discuss the rest. So let's remove the biquadratic and the cubic portions. We are going to confine your discussion in quadratic only. So quadratic equation is this type of equation. What do we see in this type of equation? The quadratic equation is a quadratic polynomial is equated to 0. So here a quadratic polynomial is equated to 0. You already have the idea that what this mean by a quadratic polynomial, right? That means the highest power of the variable should be 2. Okay, so once we have the idea that what is a quadratic equation, let's discuss about what is a root. What is the meaning of root of an equation? So yeah, let me show you starting with the linear polynomial. So let's say we have a linear equation. Let's say we have linear equation. Okay, we are not discussing about quadratic equation right now. We are starting with a linear equation. 2x plus 1 is equal to 0. This is a linear equation. Question here is what value of x? This is the variable, right? So what value of x will satisfy this equation? Let's say we put x is equal to -1. Then what is the left hand side? What is the left hand side of the equation going to look like? 2 into, instead of x, we are going to put -1 plus 1. So we are going to get -2 plus 1. This is -1. This is not equal to right hand side, right? So that means this x is equal to -1. It does not satisfy this equation right here. But let's take another value. This is the first value, x is equal to -1. We take another value, we take x is equal to -1 by 2. If we take x is equal to -1 by 2, then let's put it in the equation and try the left hand side ourselves. So left hand side, what are we going to get? 2 into, instead of x, we are putting minus 1 by 2 plus 1. So we are going to get 2 and 2 get cancelled. Minus 1 plus 1 is equal to, if you cancel it out, we are going to get 0. And as you can see that this is equal to the right hand side. Okay, when we take two values, once we take x is equal to minus 1, we can see that left hand side and right hand side, they are not equal, right? But if we put x is equal to minus 1 by 2, we can see the left hand side and right hand side is equal. So here in this equation, 2x plus 1 is equal to 0. X is equal to minus 1 by 2 satisfy the condition. So this x is equal to minus 1 by 2, we will call it as root of 2x plus 1 is equal to 0. Okay, let me show you with one more example. Let's take x plus 4 is equal to 0. Let's take x is equal to minus 4. Then look at the left hand side. Instead of x, we are going to put minus 4. Minus 4 plus 4, as we can see, it's equal to 0. So we get right hand side. So as you can see, this x is equal to minus 4. This is called root of the above given equation, x plus 4 equal to 0. So as we can see that the idea of root, what is root of an equation? We can ask ourselves the question, what is root of an equation? Okay, we can answer like this. The answer is the value of variable. So we know that this is the minus 4 is the value of x, right? And clearly from this equation itself here, x is the variable. So the root of an equation is the value of the variable which satisfies the given equation. Okay, so we have discussed what is the root of an equation, right? We have started with an example of the linear equation also. What if we are given a quadratic equation, right? Okay, let's start with an example. Let's start with an example of a quadratic equation. This is a example of a quadratic equation, x square minus 3x plus 2, a quadratic polynomial is equal to 0. Now, you have already learned in class 9. We can factorize this quadratic polynomial. We can factorize this by splitting the middle term. We can split the 3x. You can split the middle term. Okay, how do we do this? On multiplication, we have to get a value on multiplication, which should be 2. And on addition, looking at this plus sign, we should be able to get 3. Okay, let me repeat again. On multiplication, we should get 2. But on addition, we are supposed to get 3. What are the numbers? Obviously, you know it should be 2 and 1, right? On multiplication, we will get 2 on multiplication. And on addition, we are going to get 3. So middle term splitting, I'm doing like this. X square minus, instead of 3, we are putting 2 plus 1, x plus 2. Don't forget the right hand side. Then when you open the bracket, you are going to get something like this. Minus 2x. Multiply this minus and plus sign. Then we are going to get minus x plus 2 is equal to 0. So from the first two times, you can see that we can take out x as common factor. The first two terms, we can take out x as common factor. The remaining two terms, we can take out nothing as common, right? There should be only 1 as common. So we take out x as common factor. What is remaining from the first term? There is x squared here. If we take out x, then 1x is remaining, right? X minus. From the 2x, if we take out x common, then you know that 2 is remaining, right? Minus. There is nothing common between these two numbers. So we will take out 1 as the common factor. And when you take the bracket with the minus sign outside, you have to change the plus sign. The plus sign will turn into minus sign. So we are going to get x minus 2 is equal to 0. Now we have got two terms here, one term here, another term here. And as you can see, x minus 2 is on both of them. Take the x minus 2 as common factor again. So we are going to get x minus 2, x minus 1 is equal to 0. Okay, let's start with the roots. Now, let's continue with the roots. Okay, so you know that if I put x is equal to 2, what is the left hand side? If I put x is equal to 2. If I put x is equal to 2, then left hand side we are going to get 2 minus 2, 2 minus 1. Okay, look here. In this left hand side, we are replacing the x with 2. So instead of x, we are putting 2 here. 2 still remains. X, we put 2, 1 still remains. So we are going to get 0 into 1. We are getting 0, which is equal to right hand side. And you should know that here, since left hand side is equal to right hand side, x is equal to 2 satisfy this equation. X is equal to 2, it satisfy this equation above. And you should know that this equation comes from this equation, right? So we can say x is equal to 2, it satisfy x square minus 3x plus 2 is equal to 0. What do we call the variable, the value of the variable that satisfy an equation? We call this as root, right? But there is a catch here. For quadratic equation, we can also put x is equal to 2. Let me erase this. Let me erase this. Instead of x is equal to 2, let me put x is equal to 1. How do I get x is equal to 2? I get it from here. X is equal to 1. I get it from here. So left hand side, we are going to get 1 minus 2, 1 minus 1. Again, we are replacing in this equation itself. X is replaces 1, 2 remains. X is replaces 1, 1 remains. So what are we getting? Minus 1, 1 minus 2 is minus 1 into 0. So we get 0. And this is also equal to right hand side. Now we get another value of the variable x is equal to 1 satisfy this equation. It also satisfies this equation, right? So this is also a root. So how many roots do we get for quadratic equation? We get x is equal to 1. We also get x is equal to 2, right? So we get two roots for quadratic equation. So the thing that the point to be noted here, the point to be noted from solving a quadratic equation is for a quadratic equation. So this is one of the roots. We also used to get x is equal to 2 as the root. So this is another root. How many roots do we get now? X is equal to 1 and x is equal to 2. There are two of them, right? So from there, from here, from this example, from solving x square minus 3x plus 2 is equal to 0, the point that we should note is for a quadratic equation, we have how many roots? Two roots. So quadratic equation, two roots. And when we see from the linear equation that we have learned before, for example, when we solve x plus 4 is equal to 0, we get only one root. There are no two more values of x that will satisfy this equation. So here we can make notes here now for linear equation. There is one root. There is no two roots, okay? No two values of the variable. For quadratic equation, there is two roots. Okay, and then you can make a relationship also. Linear equation, for linear equation, what was the highest power? The highest power was 1, right? For linear, highest power was 1. For the variable, highest power of the variable. Okay, same thing for quadratic. What was the highest power of the variable? It was 2, right? So the highest power of the variable for a linear equation is 1. The linear equation has one root. So the number of root and the highest power, they are the same. Linear equation has one root. The highest power of a linear equation is also 1. So they are the same. Quadratic equation, we have two roots. The highest power is also 2. So the number of roots and the highest power is equal. Likewise, we can make afterwards, assumption afterwards. If we have a cubic equation, let me draw with the same color. If we have a cubic equation, we have known that the highest power is 3, right? we will have three roots. Okay, so cubic highest power of the variable is how much? This is equal to 3. So the number of roots and highest power of variable, they are the same. Okay, now let's come back to the discussion for the quadratic equation again. We have known what a quadratic equation is. We have known how many roots does the quadratic equation have. Now we are going to focus on how to find out the roots of a quadratic equation. All right. So now the question is how to find out the roots of a quadratic equation. So actually there are three methods for doing this. The first one, we will just call it as factorization method. The second one, we are going to call it as completing perfect square method. Third one, we are going to call it as quadratic method. We have already done one method, one example for the factorization method. Completing perfect square method, we will come next. Then the last one is the most important, quadratic method. Based on this method, we are going to do lots and lots of questions that is based on previous year's questions. So let me start with this factorization method. Okay, let me start here on the right hand side of my board, factorization method. So how do we do factorization method? We have already done one example in the beginning when we try to find out the roots of a particular quadratic equation. Okay, let me give another example. Another example of quadratic equation, we have got 2x squared minus 5x plus 4 is equal to 0. So how about this? Here, the middle term. Okay, let me erase this one. This is not very appropriate. Let me give a very simple one. X squared minus 5x plus 4 is equal to 0. We have already learned in 9 how to do middle term splitting, right? So where is the middle term? This is the middle term. Okay, in quadratic equation, we can separate the terms into three types. This one has an x squared in it. This one has an x in it, while this one doesn't have any variable. So we will call it as constant term. This x squared, we will call it as quadratic term. The middle one, we will call it as a linear term. So you should know that the middle one, the linear term, you have to try if the middle term can be splitted into two values so that we can make the factorization easier. So as you can see from the polynomial itself, only this portion, what the question is demanding is, if you multiply, you should be able to get 4. And if you add, you are supposed to get 5. Let me repeat again. If you multiply, you are supposed to get 4. If you add, you are supposed to get 5. So in multiplication, you're supposed to get 4, and in addition, you're supposed to get 5. What are the two numbers that can satisfy this condition? That will be 4 and 1, right? Because in multiplication, we are getting 4 into 1 is 4, and in addition, we are getting 4 plus 1 is 5. So split the middle term, the 5 into 4 and 1, we are going to get x squared minus 5 is split into 4 plus 1, x plus 4 is equal to 0. Now let's open the bracket in the middle. We are going to get x squared minus 4x minus x plus 4 is equal to 0. You take the common terms between these two and these two. In the first two terms, you are supposed to get x as the common, and between the next two terms, there is no common factor, so there is only 1 as the common factor. So take out the common factor from the first two, we are getting x. So x minus 4 is remaining. From the next two terms, we're taking 1 out. And since we have the bracket outside with the minus sign, we're putting x instead of plus, the sign will be changed into minus 4. We've got two terms here, x minus 4 and x minus 4 is common on both. So take out the x minus 4 as common factor. The first x is remaining. In the second, minus 1 is remaining. Now, in order to get the roots for this particular quadratic equation, we have this rule before. If you remember in class 9, if a into b is equal to 0, either a is equal to 0 or b is equal to 0, or both a equal to b equal to 0. We have already learned about this corollary in class 9. So we have a similar situation like this. This is a, this is b, they are multiplying, right? A into b is equal to 0. So we can put out these two conditions. Either a equal to 0, instead of a, we are going to put x minus 4 is equal to 0. And this one is b, right? So instead of b, we are going to put x minus 1 is equal to 0. So here, if we apply this condition, if we apply this condition to this portion right here, what are we going to get? We're going to get either x minus 4 is equal to 0 or x minus 1 is equal to 0. So if we do a little bit of transposition, then from the first one, we are going to get x is equal to 4, right? 0 plus 4. From the second one, same thing, we are going to get x is equal to 1. So if you put x is equal to 4 and x is equal to 1, if you put separately x equal to 4 and the x equal to 1 in this equation right here, then you are going to see that left hand side is equal to right hand side. That means these two are the roots. These two are the roots of which equation? This equation. Okay. This is one of the examples of how we find out the roots of an equation by using the factorization method. All right. Second one, and this is one of the most important, this is completing perfect square. Okay. Completing perfect square, the method says, the word says already, you have to complete perfect square, right? So one example is given. Let's say we are given with x square minus 6x plus 25 is equal to 0. You have to make this into a perfect square. All right. If you make it into a perfect square, then we can solve this instead of the factorization method that we have done earlier. So here again, you have to be aware of the terms, the quadratic terms, the linear term, and the constant term. You have to be aware of these three. And here we have to know one more thing. We have to know coefficients of the term. And you know what is a coefficient, right? What is a coefficient of a term, right? For example, if I take this term right here, you have to take along with the sign minus 6x. What is the variable? X is the variable. What is the number in front of x? We have got minus 6, right? The minus 6 is called the coefficient. Same thing here in case of x square. What is the part with the variable? X square is the part with the variable. And what's the number in front of x square? Actually, we don't see any number in front of x square. So we will assume that there is 1 in front of x square. So 1 is the coefficient. Or what? Coefficient of x square. Get it? So if there is 1, 1 is the coefficient of x square. There is minus 6. Minus 6 is the coefficient of x. We don't actually define coefficient for the constant term here. All right. So in order to do the completing perfect square method, we have to be aware of what is the coefficient of the x square term right there. So x square term is which one? This one, right? What is the coefficient? Coefficient is 1, right? So coefficient of x square is how much? 1. Now multiply this coefficient by 4. Multiply this by 4. 4 into 1, so we get 4. Now what we have to do is, you have to multiply this entire equation, both sides. Left hand side and right hand side, you have to multiply both of them by this 4. And you have to remember, how do we get 4? All right, you have to first find out the coefficient of x square, and then you multiply the coefficient of x square by 4. If there was 2 here, then we will put 2 here, 2 here. We are going to get 8, and then you have to multiply the whole equation by 8. But for this case, we're supposed to multiply the equation by 4, right? So multiply both sides by 4. What we are going to get? We are going to multiply both sides of equation above by what? By 4. So what do we get? Multiply this by 4, we get 4x squared, isn't it? So 4x squared. Multiply this number by 4, this term 6x, if we multiply by 4, we're going to get 4 6 we have 24, right? And then if we multiply 25 by 4, what are we getting? We're getting 100. You have to do on the right hand side also. Right hand side, 0, if you multiply it by 4, then we don't get anything. We just get 4 into 0 is equal to 0. Let me repeat again. We multiply this x squared by 4 into 4. We're getting 4x squared. We multiply 6x by 4. We're getting 24x. We multiply 25 by 4. We get 100. Here, this can be made into a square. This can be made into twice ab. And there should be another term, that is b square. This can be made into b square, but the twice ab, it will not match with the 24x. That's why we are going to find out what is the value of b square actually. So first one, 4x square, we can put it as 2x whole square. Keep the 24x plus 100 is equal to 0. Okay, look, this is a square. This should be twice ab. All right. So twice ab, but what is b? A is 2x. From here, what we can conclude is a is twice x, twice ab. What is twice ab? 2 into, instead of a, we are putting twice x. B, we don't know. Twice ab should be the 24x right there. So here, if you can remove these things, 2x from the 24x. If I remove x, what is remaining? 24, right? If you remove 2 from 24, that means if you divide it, you are going to get 12. If you divide it again by the 2 again, then we are going to get 6. So look, if instead of the b that I'm putting right here, if instead of the b I'm putting right here, if I put 6, you will get 24x, right? So look, let's check. 2 into 2x into 6. We're getting 24x, isn't it? That means instead of b, we are supposed to put 6. Right? So what is a? A is the 2x. Instead of b, we are going to put 6. So let's transform this equation once again. We're going to put 2x whole square minus 24x. We are going to change it in the form of twice ab like this. So we will put 2x 6 plus 100 is equal to 0. Okay, let's continue on the right hand side. Okay, we want to make a complete perfect square. We have got a square. We have got twice ab. So look, we have got a square. We have got twice ab. What we are lacking is we haven't got b square. B is how much? B is 6, right? B square will be how much? B square, 6 square will be 36. So here, this 100, we can split into two parts. One of them will consist of the b square. The other remaining will be the remaining. So we are going to put like this, 2x square minus 2x 6. Let's break down the 100 part. We will break it down into 36. This part will make the b square. The remaining will be 64, right? 36 plus 64 is 100. 64 will be the remaining part. So 100, we will split it into 36 plus 64 is equal to 0. Okay, let's make further transformation. 36, we will put it as 6 square. And the 64 right here, you transpose this to the right hand side. So what will be remaining? We will have minus 64. Okay, now as you can see from this left hand side portion, it is exactly a square twice ab and b square. So we will change it into a minus b whole square, right? Instead of a, we are going to put 2x. Instead of b, we are going to put 6, right? So continuing further, we are going to get 2x minus 6 whole square is equal to minus 64. Now, we are supposed to find out the value of x, because completing perfect square method, what was the purpose? We have to find out the root. Root means the value of x. So take the square to the other side. We're going to get 2x minus 6, close the bracket, equal to root over minus 64. And what should also, you should also keep in mind while taking a square to the other side, when you change the square as a square root on the other side, you should put two signs here, plus and minus. Why? Because minus 3 whole square is 9, plus 3 whole square is also 9. Square root of 9 means what is the value that should give the square is 9. So both minus 3 and the plus 3, it gives the value, when square, it gives the value of 9, right? So square root of 9, if 3 square is 9, if you take square to the other side, 3 is equal to plus minus root over 9. And you can do a reverse way also. Root over 9 is equal to plus minus 3, like this. So taking care of that idea in mind, you should put, when you take the square to the other side, you should put a plus minus sign here. Plus minus. Okay, now we can find out the value of x easily by doing a little bit of transposition. The minus 6, it will bring to the other side. It will become plus, right? So what we are going to get is 2x is equal to plus 6. Minus becomes plus, plus minus root over minus 64. This minus 6 comes on the right hand side, turns into plus. This remaining, it continues here. Now we can find out the value of x. Plus 6 plus minus root over minus 64 divided by 2. Look, the 2 here, it comes down as the denominator. So we find out the value of x like this by using the completing perfect square method. This is a very complicated procedure. Okay, sometimes it will be difficult to find out. It will be difficult to make out how to make out the perfect square on the left hand side, like we have done in this step. And actually, you know that for quadratic equation, we have got two values of roots, right? For quadratic equation, we have got two roots. The two roots is indicated by this plus minus sign. This plus minus sign, it indicates that you have got two roots. How do we have that? Let's see. Look, one of the values you can take as plus, another value you can take it as minus. So x, we can put it as plus 6 plus root over minus 64 divided by 2. Another value, here we have put the plus sign here. So another value, let me draw with different color. Another value of x, we can write it as plus 6. Instead of the plus sign, we will put minus root over minus 64 divided by 2. So we have got, like we have explained in the earlier, quadratic equation has two roots. From the completing perfect square method, we have got a plus minus here. When we separate the plus minus, we will get two value of x. Right. Okay, since this is a very complicated procedure, We have done factorization method. We are currently doing the completing perfect square method. Since this is a very complicated procedure, we're going to do the third one. The third one is the most important. The third one, the quadratic method. We will find out what are the value of x. We will still use the completing perfect square method, but we will assign the values of x using the coefficients. So we will do the quadratic method in the next class. For now, let's finish here.